Function f is defined for all real x by f of x is x minus x squared. Find the greatest value of f of x and the value of x for which this occurs. So we've got various ways of doing this. We could do this using calculus. Let's just do that. So f dashed x is going to be 1 minus 2x. So if we want f dashed x is equal to 0, that means that x is equal to a half. And f of a half would be equal to a half take away a half squared, giving us a quarter. So the max value of f of x is 1/4 when x equals a half. The domain of g of x is x take away x squared is such that the inverse exists. Explain why x is greater than or equal to 1 is a suitable domain for g of x. Okay, so note that as far as the rule is concerned, g is the same as f. It's just the domain that's different. Now, we know that f would be shaped like this, and this is at a half, a quarter. We established that in part A. Now g is going from, in actual fact it's from there. So when x is equal to 1 we can see that it's 0. And so this is the graph of g of x, and because it doesn't have the turning point, we can clearly say that g of x is a 1-to-1 function. Well, there's lots of other ways you could have done that. For example, you could have just shown that the gradient is always negative down here, and therefore it's strictly decreasing. It doesn't have a turning point. Again, that establishes the fact that it's 1-to-1. So the functions h and k are defined as we can see here. We want to find h of k of 10. So the 10's going in this way. So the 10 will go through the function k first. So if we put 10 in here, what happens? Put 10 into k. 10 take away 1 is 9. Take the square root of that, that's 3, and add 5. So we get 8 out here. We're then going to put that into h. So 8 plus 2 is 10. So that ends up being log 10. That's log to the base 10 of 10, which is equal to 1. So we can say h of k of 10 is equal to 1. So now we want to find the inverse of k, stating its domain and range. And we've got the domain for the original function just up here. So I'm going to let y be equal to 5 plus the square root of x minus 1, and then I'm going to interchange x and y. So x is going to be 5 plus the square root of y minus 1. So root y minus 1 is equal to x take away 5. We're trying to make y the subject now. Square both sides. Y take 1 is x minus 5 squared. So y is going to be x minus 5 squared plus 1. So we can say that k minus 1, x is x minus 5 squared plus 1. Now, one thing we should be able to spot from up here is that this is an increasing function. It will have a shape like this. So the endpoints are going to be important for determining the range. So when x is 1, 1 take away 1 is 0, so it's just going to be at 5. When it's 101, 101 take 1 is 100, square root of that is 10, so the top is going to be at 15. So that's the range for the original function. Now that's going to be the domain for this function. So the domain is going to be that x is a real and x needs to be between 5 and 15. And note, these were strictly less thans, and therefore these are as well. The range will be the same as the domain for the original function. Remember, that's that switch around where the inverse function switches domain and range with the original function. And so we've got y will be from 1 to 101.